We have received some questions about the W and the Z boson. How do they interact in the Standard Model and what is the difference between them? The W and the Z bosons are the gauge bosons of the weak interaction. The weak interactions are, for example, responsible for beta decay, where a neutron transforms into a proton and releases an electron and an anti-electron neutrino. This process happens via the exchange of a W boson. The W boson has a mass of 80 GeV, the Z boson is heavier and has a mass of 90 GeV. The W boson has a charge of ±1 corresponding to W plus and W minus, and the Z boson is electrically neutral. Furthermore, the W boson can change the flavor of the quarks. In the case of beta decay, a down quark was changed to an up quark. Weak gauge bosons mainly decay into quarks, which then form hadrons. Nevertheless, they have been discovered at the superproton synchrotron at CERN in 1983 via their decay into leptons. At the Precessing Accelerator Lab at CERN, the characteristics of the weak gauge bosons have been measured to a very high accuracy. For example, via the measurement of the Z peak, the number of light active neutrinos has been determined. The interaction strength of the weak gauge bosons is similar to the interaction strength of electromagnetic interactions mediated by the photons. But why do we call the weak interactions weak? The reason for this is the large mass of the gauge bosons. The potential which the particles feel is exponentially suppressed by the mass of the gauge bosons. Hence, the interaction range of the weak gauge bosons is smaller than the interaction range of the photon, where the potential does not suffer from this exponential suppression. The interaction range for the weak interaction is only 10 to the minus 18 meters, which is smaller than the diameter of a single proton. In summary, the W and the Z boson are the gauge bosons of the weak interactions. They have slightly different masses, and also they are electrically charged, and the Z boson is electrically neutral.